Modern discussions of educational technology usually start with hardware. We point to laptops, smartboards, and software platforms as the defining features of contemporary classrooms. This commercial definition suggests that technology is a recent addition, a series of new tools purchased to upgrade a traditional environment. However, classrooms integrated digital computing decades ago. The presence of a machine does not by itself represent a new paradigm of learning. Academic definitions focus elsewhere. They define educational technology as the deliberate, systematic process engineered to modify human behavior. Before an educator selects a digital tool, they are already employing a complex instruction method designed to cultivate specific values. Hardware functions as a conduit for lessons, but the lesson's structural framework constitutes the actual technology. To understand this field, we have to look past the screens and decode the philosophical operating system governing how we teach. The linguistic history of education reveals two conflicting methods of development. The Latin root educare means to raise or to mold, implying that a teacher shapes the student from the outside. This contrasts with educere, which means to bring forth. This second root suggests that a student possesses innate knowledge that the teacher must extract. This conceptual map illustrates the functions that emerge from these dual definitions. The central node of education branches into specific societal roles: socialization, construction, and understanding. The molding approach of educare supports the socialized branch, focusing on preparing students to operate within existing cultural norms. The extracting approach of educare powers the understanding and dialogue branches, where the goal is to build a student's capacity for independent thought. Every system must resolve the tension between molding a learner to fit a society and eliciting their inherent individual potential. We can formalize this tension into two primary objectives. The individual aim focuses on self-actualization, harmonious development, and the pursuit of maximum personal freedom. Jean-Jacques Rousseau advocated for this individual focus, arguing that the educational environment should adapt to the unique nature of the child. Conversely, the social aim prioritizes the needs of the community. It views education as a vehicle for vocational training, citizenship, and cultural preservation. John Dewey championed this social perspective, defining education as a requirement for social continuity. He saw the school as a miniature version of society, where students learn to be efficient citizens. Pure individual freedom risks societal fragmentation, while absolute social conformity can suppress the innovation required for a culture to progress. Practical systems require a synthesis. As theorists John Adams and Percy Nunn noted, individuality only gains meaning when it is developed within a structured social environment. Engineering and educational technology begins with calibrating this balance to set the ultimate goal for a curriculum. Before a teacher writes a single lesson, they rely on a philosophical foundation composed of three branches: metaphysics, epistemology, and axiology. Metaphysics asks, what is real? In education, this determines which subjects represent essential truths that students must master. Epistemology asks, how do we know? This branch determines whether we treat students as blank slates or as active participants with knowledge that must be drawn out. Your epistemological stance dictates your choice between a traditional lecture-based curriculum and a discovery-based environment. Axiology asks, what is valuable? This sets the moral and aesthetic priorities that govern the behavior of everyone in the classroom. Effectively deploying any tool, analog or digital, in the classroom requires total alignment with this three-part philosophical operating system. When we move from theory to execution, we use a process called systematic instruction. This is the actual engine used to achieve philosophical goals. Systematic instruction functions as a six-step cyclical loop, where data informs every instructional decision. Step 1 is determining the purpose. The system identifies a student's prior knowledge to set a specific, measurable objective. In Step 2, the educator selects the teaching strategy and materials needed to move the student toward that objective. Step 3 involves selecting a data collection method. The educator establishes exactly how they will measure progress and the student's growing independence. Step 4 is the implementation. The lesson is delivered consistently, while performance metrics are simultaneously gathered. Step 5 is the evaluation. Educators analyze the data to see if the student's comprehension trend is positive, flat, or inconsistent. The final step is refining the process. Based strictly on the data evaluation, the educator adjusts the strategy before the loop begins again. This feedback loop is not a seasonal review. It is a continuous, daily cycle of micro-adjustments. This rigorous cycle of data-driven refinement constitutes the actual technology of education, regardless of the tools used to execute it. Today, we utilize massive open online courses, personalized dashboards, and predictive analytics to manage learning. These digital interfaces overlay perfectly onto our existing 6-step loop. They do not represent a new way of learning, but a more efficient way to manage the classical process. Modern software excels at Step 3 and Step 5, capturing and evaluating student interactions at a scale that was previously impossible. An algorithm that automatically adjusts a student's reading level is simply Step 6, refining the process, performed by a machine. However, digital tools only amplify the underlying philosophy. If the axiology or epistemology at the base of the system is flawed, these tools will simply accelerate those flaws. Digital hardware increases the speed and data fidelity of instruction, but it does not alter the fundamental nature of the systematic instruction loop. There is a structural equivalence between the architecture of a classical schoolroom and the digital infrastructure of a modern online platform. The specific interfaces and hardware we use today will eventually become obsolete, replaced by newer mediums. What persists through these changes is the alignment of a 6-step instructional system with a deliberate philosophical aim. Educational technology consists of the engineered, systematic alignment of human development with social goals, a framework that transcends whatever hardware we choose to install in a room.